So my experiment will be utilizing Newtonian forces and kinematics to calculate the coefficient of kinetic friction between two pieces of pressure-treated pine. My independent variable is the angle that the ramp is set at, and the dependent variable will be the time it takes for the smaller piece of wood to reach the bottom of the ramp. For my setup, I have simply sanded down a long plank of wood and a smaller block of wood so that any very rough and uneven surfaces are eliminated. I will be measuring the angle with a surface level tool on my phone. I have a timer set up or a stopwatch set up in the background, and I will videotape the whole thing and play back the video to determine when I let go of the smaller piece of wood and when it reaches the bottom of the ramp. My experiment is also themed around coronavirus to make it interesting and less boring to watch. For the procedure, you first set the ramp to an angle you desire, and then you start the stopwatch and the video recorder, and then you place the block of wood at the start line at the top of the ramp and you let go, and you repeat this until all three trials have been done, and then you go stop the video and analyze the time that you let go of the wood and when it reached the bottom, and you subtract the two values to get the total time it took for the wood to reach the bottom. Here are the results of my three different angles.
So for our calculations, well, before we could begin any calculations, we must have a free body diagram because this involves force. Now that we have our free body diagram, to calculate the force of friction, we're going to calculate the theoretical force down the ramp without any friction present, and we're going to subtract that from the force down the ramp from our experiment. And to calculate the force down the ramp from our experiment, it will just simply be the acceleration multiplied by the mass of the wooden block. First, to calculate the theoretical force down the ramp is simply just mg sine theta, or plug in our values. 9.8 times 0.02 sine of 20 degrees will give us roughly 0.067 newtons down the ramp. To calculate the force down the ramp during our experiment, we must find the acceleration. To find acceleration, we'll be using equation x is equal to 1/2 at squared plus v naught t. Since v naught was 0 because we started from rest, that entire thing cancels out. And plugging our values, 0.638 is equal to 1/2 a. For t, we must find the average of our times during our three trials, which is simply just 1.18 seconds. So 1.18 squared. And then if we solve for a, we will find that .916 meters per second squared. And the force down the ramp for our experiment will be 0.018 newtons. And then to find the frictional force, simply subtract the two, which will yield about 0.049 newtons. Finally, to calculate the normal force, it's simply just mg cosine theta. So 9.8 times 0.02 cosine theta should be about 0.18 newtons.
Here's my final graph. On the y-axis, I have graphed the frictional force, and on the x-axis, I have graphed the normal force and then found the slope, and the slope is the coefficient of kinetic friction. For my percent error, I got around 31%, which is not great, but it's pretty good considering I did this at home with household materials. One potential source of error is not calculating the correct amount of time it took for the wood to reach the bottom, because I don't have a high-speed camera, I only have my cell phone, and it's sometimes hard to see when it reaches the bottom when it's a blurry mess. Another source of error is me not sanding down the wood perfectly flat. There might have been some micro bumps I couldn't see, I don't know, but I think I did pretty good with what I had. Finally, the Sharpie I used to write the letters on the ramp itself might have affected the friction coefficient of friction of the surface. The improvements that could be made on this experiment are pretty obvious. Having access to better or more accurate measuring tools will definitely help your results, and also better materials. Finally, using an apparatus rather than my fingers to let go of the block of wood will probably increase the accuracy of the measurements. One limitation I faced using house mode materials was not having access to a LabQuest and a PhotoGates to measure velocity and accelerations. Also, having access to an electronic scale will probably give me a more accurate mass of the block of wood. Instead, I had to use this depressing little thing. Well, that is it for the actual physics part. The next part is just there for pure entertainment, nothing else.